Hello everyone, my name is Uzair Pavaskar and I'm from University of Wales Trinity of St. David, Swansea. Welcome to this video demonstration where I'll be showing you some deep learning modules for image recognition and we will go through this thoroughly. Let's get started. So first, let's check our data, what we have here. This is the data set that we have been provided. It has two folders, test and train, in which there are three, four, five, six, seven, seven emotions, distinguishedly all of them provided. So these are images. So we have to do some machine learning modules on this. So let's get started. So first, the data set was in a zip file. So I tried to train the train and test all. So we try to unzip our file and put it in a folder where we can access the files of the data in a particular manner. Then we have to check how many files do we have in which folder. So this is how we are gonna transverse in the folder where the training sets we have in angry 3000 pictures, in happy 7000, neutral we have 4000 something something, and in the test sets we have similarly. Now what we are going to do is we are going to make a model which we will rely on to we will make a image recognition model in different types of neural networks, such as convolution neural network, CNN, Inception, VR, RSNet, and be, based on these architecture of the models, we will try to tune the hyperparameters so that we have utmost accuracy in determining what kind of images are actually providing the same scenarios. So first, we will try to make it easier so that files that we access it's a pretty quick manner, so we will may loop through each subdirectory and make it into a cv file so that we have the same file of same format and same access, and it is very easier for us to transfer to the folders. Next we will start developing our model in which we have made a convolution network where we will load the corresponding images from one file folder, and then we will try to make sure that each image has been to the optimizer and performance measure. So the performance is I'm measuring is by three things: accuracy, precision, and recall, in which I have developed. This is my first model where I was working on. Is the It contains about six, seven layers in total, in which one is a dense layer and we have one output layer with seven neurons. These are the test images that I have confirmed that these this is a test block on from the entire data set that we have, and we will try to demonstrate if this test block our model can determine the exact emotions the image is trying to converse. In the next model that I have been trying to compile is that once the model has been in this, we have created the model now. So let's get into the model and try to put our images and train the model as per the dataset has been given, and we will try to show the lossless curve classification report, and confusion matrix. So this is how when it runs, it shows us everything on each layers. This is about 11 layers in total. This model is sequential model, and it took me around 8.5 hours to run this model because I don't have a GPU in my laptop. So if don't worry, if you don't have a GPU, it's not gonna be that big of a difference. It could take a little more longer or a little more shorter, but it is almost the same. If it's good that if you run on a GPU, then it's very pretty faster in like 3-4 hours maximum. Alright, so around 50 approaches that I did after training and validating the entire data set, I got this graph which has validate training accuracy above this much and validation, and this is my epoch loss left curve. This is my confusion matrix for the same classification report and confusion matrix. So this model is not that precise that we are looking for. So we are going to try a bit more advanced model, maybe RSNet or Inception 4, depends on which hyperparameters we try to tune, and let's get into it. So this is the predicted class that if you can see that it is pretty much, if the pictures are pretty much clear, then the model is able to determine what kind of picture is trying to show, and it somewhere it is somewhere it is working fine, somewhere it's a little bit here and there because the model is not very precise right now. We need to train this model with a lot of set of images, and we need to build a new model which will work on this. So let's save the entire model and we'll try to train more on this model. So this is the classification report, on the second model, and we will try the RSNet now. So this is the RSNet model that I have tried. So in RSNet 50, we will, on the same side, we will just run on the already trained model that we have in our hand, and we will try to print the confusion matrix and classification report, and we'll try to examine what are the hyperparameters that we can tweak, and what is the output that we are getting right now. So after about 6 to 7 hours, the this is what we get from RSNet. This is the classification report and confusion matrix. So it's a little bit better from the previous model. Now we will look into the Inception 4. I believe Inception 4 could be the best model for this particular data set as we are looking forward into this. And we can tweak a little bit hyperparameters so that the model is not very complicated for my PC to run, or it would take days or months to run this entire model in training mode. So I have used a tuner and validated a random search, and this is how the tuner is gonna run through the epoches and make a random search on the trained model that we already have, and we will get some trained hyperparameters which will be uh, good for our testing accuracy. So this is how it would look. And lastly, we will try to, in one final model, we will just try to run the all the training, validation, and test sets with the hyperparameters tweaned out. This is a sequential model. These are the hyperparameters to search the learning rate, number of classes, 12 lambda, dropout rate, and activation. Activation have you used as Zelo, and the dropout rate, so that there is if there's a dropout, we will know that how much are we losing the data from while training into it. So yeah, this is pretty much it. Thank you so much.